When writing smart contracts, there's a lot of best practices that you should follow and vulnerabilities you need to avoid. So today we'll be going over the 30 best practices for writing smart contracts. My name's Anthony, and for those of you who are new here, I'm with DDG, and we help turn you into Solidity ninjas and smart contract security auditing experts. So if you like what you watch, please like and subscribe for more content. Let's get started. The first best practice, and in my opinion, the most important, is to follow the standard checks and effects interactions pattern. So what this means is when you write a function, you put your standard checks for, let's say, checking that the message.sender is equal to owner. Then you want to update, for the effects, you want to update your state variables. And then the interactions, you want to call out to other smart contracts and transfer funds and things along those paths. This checks, effects, interactions patterns helps to prevent reentrancies. The second best practice is the principle of least access. From those of you who come from a software engineering background, you are probably familiar with this concept of only authorizing users to have access to functions that they need and not giving them full access to everything. Best practice number 3 is to utilize proven and tested libraries, for example, using the Open Zeppelin library, which has pre-built ERC20, ERC721, 1155, pre-built tested libraries. While best practice number 4 is to write tests alongside your smart contracts. Best principle number 5 is to test each function and the desired results while writing the functions. So if you have a function that you know needs to return true, you write through all the functions to make sure you get the return value. While best practice number 6 is to test for fail cases. So in that same function, you want to make sure that you're testing that the require statements are being properly triggered. Best practice number 7 is you want to make sure you keep your contracts simple, which leads right into best practice number 8, which is abstracting out your contracts so that you don't have these large monolithic smart contracts, but you have the logic abstracted out into different smart contracts so that you can easily identify should something go wrong. Which leads us into best principle number 9, which is to always expect that something is going to go wrong and to plan for the ability to pause your contract or disperse funds. Also, best practice number 10 is to also think like that every black hat is going to be trying to attack your smart contract, because you never know. They very well might be. Best practice number 11 is to audit your smart contracts throughout development, meaning you want to continuously check for common vulnerabilities and seeing if you can break your own contract. While best practice number 12 is to keep in mind how the blockchain actually works, how external contracts can actually execute malicious code within your smart contract. Best practice number 13 is to keep in mind gas limits and gas costs. As smart contract developers, our goal is to keep the gas costs and gas limits as low as possible. Best practice number 14, do not use block.timestamp or block.number, as miners can easily manipulate that. Best practice number 15, private data is not actually private, and anyone with the slightest bit of blockchain knowledge will actually be able to figure out what is actually stored in those private variables. Best practice number 16, write modular code and modular smart contracts. Similar to the earlier point of abstracting out your smart contract, you don't want to keep all your logic into one single file, but abstract it out so that you can easily identify any bugs or errors should they arise. Best practice number 17 is the proper use of assert, revert, and require. Using these statements can help prevent unwanted interactions within your contract. Number 18 is to be aware of rounding integers and how Solidity rounds down, which can ultimately lead to vulnerabilities, which leads right into our next best practice of number 19, to utilize numerators and denominators to avoid these rounding issues. Best practice number 20 is to keep fallback functions simple. So a fallback function is when someone makes a call to your smart contract that the function does not exist, or someone sends funds to a contract that has no receive function. This fallback function would trigger. So you want to keep the logic in there simple, even if it's as simple as just putting a revert statement. Best practice number 21 is the proper use of the payable keyword. Payable modifier allows Ether to be sent through a function but it does require a bit more gas. So only use the payable keyword in the applicable functions. Which leads us into point number 22, using the proper use of visibility, meaning external, public, private, and internal. You want to make sure that you limit the access control of these function modifiers so that not everybody can call a function that should only be called by an internal by another contractor by itself. For number 23, you want to avoid using transaction.origin as it can be used for phishing attacks, and you want to primarily focus on message.sender instead. Best practice number 24, you want to comply with the current ERC and or EIP standards, as these are the most up-to-date processes and protocols. While number 25, you want to utilize the current best practices and standards. For example, you want to use .call instead of .transfer, as that is the current best practice. Similar to the previous best practices, for best practice number 26, you want to pay attention to the pragma statement and the compiler. Earlier Solidity versions don't have the same fail-safes and securities that the newer versions have. For example, in Solidity version 0.8 and higher, we have the safe math library built right in for arithmetic overflow and underflow, while the earlier versions do not. Best practice number 27 is to understand how storage and memory works within the blockchain, how storage variables are stored, how memory works, and things along those lines. Number 28, you want to understand the call stack and how fallback receive functions play a part in that. Number 29, you need to utilize reentrancy guards and other modifiers to help follow the checks, effects, and interactions flow. Number 30, pay attention to arithmetic overflow and underflow. A bonus best practice is to utilize tools like Slither and Visual Solidity Developer to identify common bugs and to visualize your smart contracts and how they actually are interacting together. Thank you to all of those who stayed to the end and watched. Please like and subscribe for more. If you have any questions, recommendations for videos, need any help auditing a smart contract, or want to hire us to help get your DApp off the ground, feel free to leave a comment or shoot us a direct message on Instagram or YouTube or whatever works. Thanks for staying to the end. Catch the next one.